This video is on solving right triangles using trigonometry. If you're given a right triangle and you have two side lengths, you can find the third side length using Pythagorean theorem. However, what if you're given two side lengths and you want to find the angle measurement? You cannot use Pythagorean theorem for that. What if you are given one side length and one angle measurement other than the right angle? So if you're given one of the smaller angles, how would you find an additional side length? We're going to use trigonometry. Now, trigonometry, there is an acronym that we use for trigonometry, and I would call this trig as well. The acronym we use is SOHCAHTOA. It's an acronym where every letter stands for something. Now, if we look over at this right triangle, I'm going to explain what each of these letters represent. But if we look over at this right triangle, we see that we have this angle marking down here. Now, this is a Greek letter, and it stands for theta. Theta. Now, down here I have where we can write out the definition of theta. This is spelled T-H-E-T-A. Theta. Theta. This is a Greek letter, and it's used to represent or / reference an angle. Now, please understand that this is actually an acute angle. An acute angle that is our acute angle. Theta is that acute angle. Both of these angles have to be smaller than 90 degrees because in order to have a triangle, you have in a right triangle, you have 190 degrees. These two have to add up to 90 degrees to make a triangle. So, with regards to where theta is located, we have sides with regards to theta. Now, the first side you should always know, always, in a right triangle is your hypotenuse. I'm going to always highlight that so that I know what my hypotenuse is. This is always your hypotenuse. I'm going to turn this so I can write it. This is your hypotenuse. And this is always called your hypotenuse. It can never be called anything else. Your hypotenuse is always opposite the right angle. So it does not matter where theta is located because your hypotenuse is always in the same spot. But the other two sides, the legs of your right triangle, can actually be called something different with regards to theta. Because if you don't have all the sides, you can't use Pythagorean theorem. If you don't have the two sides, you can't use Pythagorean theorem. But you also cannot use Pythagorean theorem to find an angle measurement, to actually find what degree theta is. But you can use trigonometry. So what are these two sides called with regards to theta? Wherever theta is located, and theta can be located up here, so you have to make sure that if your picture is turned, you can still know what side is what. It's because it's with regards to theta. This side over here, with regards to theta, if I want to get from theta to this side, this is through the triangle, this is called your opposite of theta because you go across the triangle. So this is called your opposite of theta. Now, opposite of theta can change if theta changes location. So if theta were to come here, the opposite of theta would actually go to the other side. So again, it's always with regards to of theta. Where's your theta located? So then we also have this side right here. This side is right next to theta. This is called your adjacent to theta. Adjacent to theta, because it's directly attached to it. Now, again, the hypotenuse is always called your hypotenuse, so that's one of the reasons why we highlight that in yellow, to know that that is in fact your hypotenuse. You can never call this the adjacent to theta, ever. It is always called your hypotenuse. So now we go on here and explain what each of these letters represent. Now we have an S, O, H, C, A, H, T, O, A. We have a couple of the same letters. The O's stand for the opposite. The H's would stand for the hypotenuse. And the A's will stand for the adjacent. So the O's, the A's, and H's we already know. So what does the S, the C, and the T stand for? That's when we use our calculator. We have an S, a C, and a T together, these three buttons. This is what the S, the C, and the T stand for. Now, if you see this word, this is an abbreviation of the word because we can't put the entire word on these buttons. The S stands for sine. S-I-N-E. Sine. You do not pronounce it sin. This is sine. The O stands for opposite. O-S-I-T-E. The H stands for hypotenuse. P-O-T-E-N-U-S-E. Hypotenuse. So we have sine, opposite, hypotenuse. And I'm going to explain what you actually do with that. Then comes the C. So this one is a C-O-S. This is pronounced cosine, not cos. This is cosine. C-O-S-I-N-E. Cosine. The A was that adjacent. So A-D-J-A-C-E-N-T. And the H again stands for the hypotenuse. H-Y-P-O-T-E-N-U-S-E. So we have cosine, adjacent, hypotenuse. And the last one, that T, T-A-N, stands for tangent. Tangent. T-A-N-G-E-N-T. Now you can pronounce this as tan. You can say tan or tangent. For sine, you have to pronounce it as sine, and cosine, you have to pronounce it as cosine. Tangent, you can pronounce it as tan. The O again stands for opposite. And the A stands for adjacent. So what does that really mean? So what we're dealing with, trigonometry is you deal with trigonometry ratios, trig ratios. Ratios are fractions. So what we're going to end up having is I can also pronounce this as SOHCAHTOA. SOHCAHTOA. S-O-H-C-A-H-T-O-A. These go together. S, O, and H go together. C, A, and H go together. T, O, and A go together. So I have to make sure that my letters are actually together. So what this means is I'm going to write out what it actually represents with regards to for the acronym. Sine, if you type it in your calculator, if I press in sine, it comes up with a parenthesis. S-I-N of. It'll be sine of theta is equal to. So the trig ratios, sine is equal to, it's a ratio, it's a fraction. It's the opposite over the hypotenuse. So it's the opposite of theta divided by the hypotenuse. That's what the SOH tells you. It tells you so that you have it in order. It reminds you of what letters go with what, and then what order it goes in. So the sine is equal to the opposite over the hypotenuse. It goes in order. So if we do this next one, the c part of it, this is cosine is equal to the adjacent over the hypotenuse. So it would be cosine of theta is equal to the adjacent to theta over the hypotenuse. And then we'll have the tangent of theta is equal to the opposite over the adjacent. So tangent, or tan of theta, is equal to the opposite comes first, so opposite of theta over the adjacent to theta. Now, this theta, if it's written like this theta is actually always going to be an angle measurement. It always must be an angle measurement. Theta is always going to be a degree. So must be of an angle measure, which is a degree. So it might say tan of 30 degrees, tan of 40 degrees, sine of 18 degrees. These are all the same. It'll be an angle measurement. So sine of a degree, cosine of a degree, tangent of a degree. So what you can use this for is you can use it to solve for a side or an angle. So if I wanted to actually use trigonometry to solve for a specific side, I would be given one side and one angle. So to solve for a side, you actually set it up the same way you see it over here. So you would have sine of theta is equal to your opposite over your hypotenuse. I'm going to abbreviate it. You would set it up the same way. Your cosine of your angle would equal to your adjacent over your hypotenuse. And your tangent of theta would equal to your opposite over adjacent. You'd set it up the same way. Now, when you're setting it up, you're going to have a number inside the parentheses, and you'll have one, either the numerator or the denominator. You'll either have your numerator or your denominator. If you were given, so again, you'll have your theta, because if you're solving for a side, you'll be given your theta. If you're given your denominator, if you're given the denominator, you'll actually do your denominator, your number, times the trig of theta. What that means is you'll take your denominator and multiply it by the sine of theta, or denominator times the cosine of theta, or your denominator times the tangent of theta. So that's why I just put trig. However, if you're given your numerator, if you have your numerator, you'll actually take your numerator, your number, whatever that numerator was, and you'll divide it by that trig of theta, whatever that trig is. So you would have your numerator divided by sine of theta, numerator divided by cosine of theta, numerator divided by tangent of theta. So you're either going to do, if you're given your denominator, you'll multiply it. If you're given your numerator, you'll divide. So you can also use trigonometry to solve for an angle measurement. So if you're giving two sides, you could find the third side using Pythagorean theorem, but if I asked you to find an angle, you would have to do something different. So this one is set up slightly different. You would do, instead of just sine of theta, you would actually do sine inverse. So you do the sine to the -1, and then you would actually keep the same fraction of sine. It would be opposite over hypotenuse. Opposite over hypotenuse. That will actually give you your theta. So for the cosine, you'll do the same thing. So cosine inverse of the adjacent over your hypotenuse. That will give you your theta. And then tan inverse of opposite over adjacent will give you your theta. Now again, what that really means, this to the -1 part here, that means the inverse, because you're doing the inverse operation. That means inverse. So sine inverse, cosine inverse, tangent inverse. So to do this, you would actually press the buttons second sine, and then type in your fraction, or second cosine, type in your fraction, or second tangent, and type in your numbers. So if I look over here, if I do second sine, it comes up with the inverse part, and I would just type in the fraction, and that would give me my degree. So this is how you use it to solve it.